I am welcoming you to this video where we are looking at a physics problem at the 12th grade level. I am Mr. Ish. Thank you for joining me. We have an object which is shot straight up from a 2000 meter height. We have to determine the maximum height and the time of impact of that object at sea level. Given the initial velocity, the object was shot straight up at 100 meters per second. The best way to handle this type of problem is to draw what you have. You have a certain height over here, and you know this is 2000 meters. Right here at my 0 meter level is the sea level. We have an object that's shot straight up. It's going to be shot up at 100 meters per second. It's going to reach a certain maximum height, after which it will come down, assuming it's not going to land down here at the top of your height, but it's going to come all the way down to sea level. We have to determine the maximum height and we have to determine the time to impact. How do you do it? The best equations you have available to you are S is equal to half AT square. Also VF is equal to VO plus AT. Position of an object is equal to half AT square. The final velocity is equal to initial velocity plus acceleration times time. When an object is shooting straight up, it is contrasted and worked against by gravity. Here, gravity must be a vector pointing downwards and opposing it. Therefore, your acceleration or your gravity should be a minus value. If you don't have that minus value over there, we can have a problem. Also consider this: when an object is thrown straight up, eventually it will turn and come straight down, right? There's a specific point right here where that occurs. At that specific point, your final velocity is going to be 0, because the object is going to briefly stop for an instant period of time before it turns the vector direction around and it comes downwards. At that specific point, we have a final velocity of 0. Keep that in mind. And that right there, tidbit, tells you everything you need to know. And look right here. We have a final velocity of 0 is equal to initial velocity 100 plus AT minus 9.8 t. I'm solving for this time to maximum. The time for the ball to reach maximum height, or the object to reach maximum height. Minus 100 is equal to minus 9.8 t. T is equal to, you divide that, 100 divided by 9.8. It's going to take 10.2 over here to reach the maximum height. 10.2 seconds. Why do I need this? Because I need to determine the maximum height by this equation. S is equal to half AT square. The maximum height. I'm going to throw a ball. It does not matter where the ball was thrown from, sea level or that. We're just determining the height from this equation. Then we'll determine the maximum height. Half times 9.8. Here it doesn't matter the vector direction. We're looking upwards for the maximum height. You can keep it positive. And then 10.2 square. Do this determination and see what you get. You'll have 9.8 times 10.2 square divided by 2. Maximum height here is 509, which I'm rounding up to 510 meters. 510 meters. Relative to the height of this cliff, it's 510. But relative to the sea level, it's 510 plus 2000. So your maximum height will be 2510 meters. Now we have to do our last rider, time to impact. And that equation is easy. It's right there before you. The time to impact of this object here at sea level is not a difficult computation. I already have the 10.2 seconds saved from before, the time it took to reach maximum height. Our maximum height is this 2510. You can put everything here in this equation. 2510 is equal to half AT square. If you solve for this time, it's giving you the time it took to reach the ground from this height down here. It's not accounting for the fact that it took 10.2 seconds to first arrive at that maximum height, and then this time to actually descend all the way down. The time to impact would be the sum of both of these values, and we will determine that. Also consider the fact that since everything is now going downwards, from this point on you can keep acceleration positive. You'll have 2510 times 2 divided by 9.8, then obviously you're square rooting it because there's a t square. You take this computation, it's not hard. You'll have 2510 times 2 divided by 9.8. You square root that, you get 22.6 seconds. 22.63 seconds. What does it mean? From the maximum height down to sea level, it's a 22.63 second trip. But from the time the object was shot up, you have to add that in, because it's talking about the time to impact. The time to impact starts from the time the experiment was started or the object was shot straight up. And this right here would be your answer. 32.83 seconds. Of this 32.83 second total trip, 10.2 are involved or spent reaching the maximum height. The remainder spent in arriving here at the sea level. And you can see everything here is before you. This answer here is good, this answer here is good, and you can see the two breakdowns of the time based on the two different paths, the going up and then the full descent all the way down. Have a good day.